This is GCSE Electricity Lesson 5, and this is the IV characteristics of a bulb, or filament lamp. So the objectives are to explain how we set up the experiment for measuring the IV characteristics of a bulb, and be able to draw the IV graph of a bulb as well. So first of all, I'll talk about the circuit setup. So first of all, we're going to need a power supply. And then from that power supply, we need to go into an ammeter to measure current. Well, the power supply should have, so there's a fact, let's get rid of that. Let's have 2. Then we can go into a variable resistor. So I've said this before, but this is essentially the power supply, a power pack that you might use at school. Right, let's finish this off. A little bit more actually. Then we need the component, so we're looking at, that's possibly the worst circle I've ever drawn. Let's try again. I'll do. So that's the filament bulb. So let's put the cross in. There we go. So we've got the ammeter in series to measure the current values, and then we need to put the voltmeter in parallel across the component. So I can draw this. That's not too bad. Voltmeter. So that's the diagram, that's exactly how you should draw it. Then we need to select some values. So you could have, for example, a 12 volt bulb. And for a 12 volt bulb, you might want to go from 0 to 12, but do it in 2 volt intervals. So we'll have voltage measured in volts, and then we've got current measured in amps. So in this investigation, you're essentially going to change the voltage and measure the current. So we'll come back to that in a moment, but you'll start at 0, and then you might go +2, 4, 6, 8, up to 12, and then switch the leads around at the power pack to change the direction of the current, and then -2, -4, all the way down to -12. So that's 6 readings aside, and that can give you a nice graph, which I'll show you in a moment. But just back to the variables, the thing that we're changing, which is the independent variable. So the independent variable, the thing that we change, is the voltage. Then we've got the dependent variable. Oops, ignore that. Dependent variable, which is what we're measuring, so that's what we measure. And the thing that we're measuring in this experiment is the current values. If you've got a 6 volt bulb, you might go +1, 2, 3, 4, 5, 6, and then -6. Give you a nice spread of results. But make sure you check the bulb first. And what you should do is plot a graph of current against voltage. So current in amps, voltage in volts. And the reason why it's like that, the x-axis is the independent variable, so that'll be voltage. Y-axis has the dependent variable on. So the graph will look something like this. And we've got some very typical questions. So this bit, the straight line bit, well, basically a straight line. That region is the same as the resistor from the previous lesson. That region's ohmic. So in this voltage range, so it's ohmic, so V is proportional to R, or it obeys Ohm's law. So Ohm's law will actually work in that region. However, it starts to curve off, as you can see, and when it's no longer a straight line, when it's not linear, Ohm's law doesn't work. And you can take a tangent at any particular point, but you definitely won't need to do that for the GCSE. So, what you are asked a lot of is, why does it do this? And it's quite straightforward. So why does the resistance of the filament lamp increase with increased current? So as you can see, there's more current, more voltage. The current's going up, but it starts to go up less and less and less, and that's because the resistance is increasing. So as the current increases, the filament gives off heat and its temperature increases. This rise in temperature makes the atoms in the metal vibrate more, and this in turn makes it harder for the electrons to flow through it. This raises the resistance of the filament. So that's a full explanation of how it works. And other talking points to the graph might be that the forward bias, so this is the forward bias, gives the exact same shape graph as the reverse bias, which is the same as the fixed resistor graph from lesson 4. All right, let's move on from there. Oh, and this ohmic region, partial to I, not R. Sorry about that. Right, let's do some exam questions. So if let's pause and have a go at this one. So why is the component labeled J included in the circuit? So J, remember, is a variable resistor. So it's included in the circuit to alter or change the voltage across the filament bulb. And incidentally, the current. So the resistance of the bulb increases, the potential difference across the bulb increases. Why? It's only a 1 mark answer. So you could just write temperature increase. Okay. All right, let's move on. So if you want to have a look at this one. So the current through an ohmic conductor is directly proportional to the potential difference, or voltage. I'll just write PD. Provided that the temperature remains constant. It's got to be at a constant temperature. I'll just write temp. And then this one, compared to the question which we just did, by just did I mean this one, the resistance of the bulb increases. That's only worth 1 mark, so you can just say, well, temperature increases. If you look at this one, it's saying explain. So it's a totally different type of question. And you might realize that this graph is just, the upper right quadrant rather than, and it's kind of chopped off the bottom left, the reverse bias. So explain how the resistance of the filament lamp changes as the PD across it increases. So the current increases, which causes the temperature of the filament bulb to increase, or filament lamp, or just filament. Therefore, the resistance increases. Really nice and straightforward. 3 marks. Logical answer. You can say voltage. I would have written, change, increase voltage, increase current. Temperature of filament increases. Therefore, resistance increases. So hopefully our answers, along those lines. But that's it for IV characteristics of a filament lamp. Hopefully that went okay. And the next one will be on semiconductor diode. Thanks for watching and take care.